Hey there, calculus. So here's page 3 of the review, episode 3 of some Thanksgiving math. Okay, so for number 8, if you look at this one, you don't need to do any u-subs on this. This is just a regular integrate because I don't see anything too complicated. So what's the integral of 1 over x? That's ln of absolute value of x. And then the integral of 2x is 2x squared. We can write it up here if you want to. 2x squared over 2, which just simplifies 2x squared. And then we're evaluating this from 2 to 6. Notice I'm not changing boundaries because I did not do a u-sub. So when we plug this in, remember, make your little template here, right? Top minus bottom so we could plug it in. So when I plug in the 6, I'm going to have the ln of 6. And if I plug in the 6 into there, I get plus 36. 6 squared is 36, right? And then minus, if I plug in the 2, I'm going to get ln of 2. And then 2 squared is 4, okay? Now let's get rid of those parentheses. So I have ln of 6 plus 36. Distribute that negative, minus ln of 2 minus 4. If I combine some like terms, I have the ln of 6 minus the ln of 2. And then 36 minus 4 is 32, so plus 32. Now, here's where, like, this might get you. So I know that I have a 32 in my answer, so it looks like it's either going to be A, C, or E. So it's not going to be D or B. So they did something with these ln's to combine them. Now, you guys, we've gone over this several times. Let me remind you again. If you have ln of A plus the ln of B, this is really equal to the ln of A times B, okay? If you're subtracting ln of A minus the ln of B, this is really equal to the ln of A divided by B, okay? So that's what we want to use here. So because we're subtracting here, I can rewrite this as the ln of 6 divided by 2 plus 32. And 6 divided by 2 is 3, so this is the ln of 3 plus 32, okay? Leaving me with the answer C, all right? Okay, number 9. You guys, the way I did it on my written out review sheet is another way to do this one, but you could actually do long division on this, and it works out just fine with that as well. Okay, so if I do long division on here, let's set it up. So I have x minus 1, and we're dividing that into x minus 2. Okay, it's kind of a silly long division one, but does help. So what do I have to multiply x by to get x? Kind of a silly question. I have to multiply that by 1. When I multiply by 1, I'm going to get x minus 1. Then I'm going to draw the line and change both signs. These cancel. Negative 2 plus 1 is negative 1. So this is really equal to 1 and then minus the remainder, which is 1 over what I divided by in the first place, okay? So let's go ahead and transform this integral. So this integral is the same as the integral of 1 minus 1 over x minus 1. Now remember, when you're doing this, you're going to have an easy part and a hard part, and you need to separate those two apart. So integrating 1 is easy. Integrating 1 over x minus 1 is a little bit harder, so I'm going to split the integral right there. And let's go ahead and do it. So the integral of 1 is just x. So I know I'm going to have an x in my answer, which means that A is out. And that's about it. Okay, and then I have minus. Now to do this part, I'm going to have to do u sub. What do you think your u is going to be? So for this guy, I don't even know where to write this. My u is going to equal the bottom part here, the x minus 1. And my du is just going to be my 1 dx. Okay, so let's do the u sub. So I have the integral of 1 over the x minus 1 was my u. The dx becomes the du, and there is no leftover. So integrating this, I get x minus the integral of 1 over u is the ln of absolute value of u, which is going to be x minus the ln of the absolute value of the u was x minus 1, and then plus c. So we've got, let's see, that looks like C to me, does it not? Yep, it's C. All right. All right. Number 10 is a gross little problem. I actually really hate this question, but it's okay. We can do it. Okay, so I see like a really disgusting square root in here. Let's see if we can simplify that a little bit. So I can rewrite this as the integral from 0 to 5 of the square root And let's do 5 divided by 5, which is 1, minus, and then x divided by 5 is x over 5, and then dx. Okay? And maybe that might help me when I do my u sub to maybe kind of like do stuff in here. Okay, so what do you think your u is going to be? I'm going to make my u all the disgusting stuff inside that square root, which is 1 minus x over 5. Then your du is going to be, well, the derivative of 1 is 0, okay, minus the derivative of x over 5. You guys remember x over 5 is just a fancy way of saying 1/5 x. It's the same thing. So the derivative of 1/5 x is just 1/5, and then dx. Okay, so let's go ahead and do that u substitution. So I'm at the integral of the square root of all of this right here became your u, right? So that's the square root of u. Now your dx is going to become your du, but then I have this leftover negative 1/5, so I have to multiply by the reciprocal of that, which is negative 5. Okay, now boundaries. Yeah, I need to change those. Okay, if I plug a 5 into here, I'm going to get 1 minus 5 over 5, which is really 1 minus 1, which is 0. And then if I plug a 0 into there, I'm going to get 1 minus 0 over 5, which is really 1 minus 0, which is 1. The changing of the boundaries was not really that bad. Now let's go ahead and integrate this. So this is negative 5, integral from 1 to 0 of u to the 1/2 du. Okay, now some people might be like, should we change the boundaries and get rid of the negative? Why not? Let's flip the boundaries around and make this a positive 5 and go from 0 to 1u to the 1/2. Okay, anything to make it easier. If it gets rid of a negative sign for you, do it. All right, now let's integrate this. So this is 5. If I add 1, I'm going to get u to the 3/2, but then I have to multiply by the reciprocal, which is 2/3 from 0 to 1, which is, let's go ahead and multiply this thing out. 5 times 2, that's 10 over 3. And then if I plug in a 1, right, I'm going to get, if I, actually, let's just rewrite it. I'm doing too many steps here. This is u to the 3/2. U to the 3/2 really means the square root of u cubed, evaluated from 0 to 1. If I plug in the 1, I'm going to get 10/3 times 1, minus if I plug in the 0, I'm going to get a 0. So this is just going to be 10 over 3. Okay, I've never liked that problem. It's really complicated. All right, it says f double prime. Oh, that should like, I don't know if I wrote this. It should look like this. Sorry. F double prime is 24x. F of 0 is 1. F of 1 is 7. Find an equation for f of x. Okay, this is a really old question. Okay, so look, if I know that f double prime of x is 24x, and I need to get to f of x, this means I need to start taking integrals, right? So let's take the integral of both sides. So the integral of f double prime is f prime of x, and that's going to give me 2x squared over 2, or just x squared plus c. Okay? Now I can't really plug in any of these guys because there's no f primes there, so I'm going to keep on going. If I take the integral again, let's do a different color. The integral of f prime is f of x. So this is going to be x cubed over 3 plus the integral of c is cx, and then plus another constant d. Okay, so now I have to find that c and that d. Now, you guys, I'm going to start with this guy first, the f of 0 equals 1, because this is telling me that x equals 0 and y equals 1. That's easy to plug in. So look, f of x is another name for y, so let's replace everything. If the y equals 1, I'm going to get 1 equals, and it said that x equals 0, so I'm going to plug in 0. 0 cubed over 3 plus c times 0 plus d. So this is 0, this is 0. So I just got that d equals 1. Okay, so let's put that in there. So now I have f of x equals x cubed over 3 plus cx plus the d equals 1. Now I still have to find the c. So now I'm going to use this one right here. The x equals 1, the y equals 7. So remember, this is just another way of saying y. So it's 7 equals, replacing the x with 1, I'm going to get 1/3 plus c times 1 is c plus 1. And then solving for this, so I have 7 equals, see, 1 plus 1/3, that's 1 over 3 plus 3 over 3, which is 4 over 3 plus c. So if I added these guys together, right? And then 7 minus 4 over 3 equals c. if I find myself a common denominator here, I have to multiply this by 3. So it's going to be C is 21 over 3 minus 4 over 3. And 21 minus 4 is 17 over 3. Okay, kind of a gross little answer, but it's okay. So what's my final answer going to be? So I have f of x equals x cubed over 3. The C value I just found was 17 over 3, x, and then plus 1. Okay? So there is that. Okay, oh my gosh, children, do you see what I did? I have to redo this problem. I'm so sorry. I copied it down wrong. This is 24x. I wrote 2x. All right, let's erase it and do it again because I really don't feel like starting from scratch on this. Oh, well, happy Thanksgiving to everyone. It's all right. Let's erase everything. You're going to have to wait as I erase because the iPad reformatted, and now erasing has become a complete pain. Sorry as I'm sighing. I like literally want to cry right now. I just noticed that too. I'm like, why is my answer coming out so weird? It's because Cruzy doesn't know how to copy over problems. Okay, so let's pretend we're doing number 11 all over again. So I have f double prime of x equals 24x, not 2x. Okay, so let's integrate. So I'm going to integrate this. So I'm going to get f prime of x equals, this is going to be 24x squared over 2, which is really 12x squared plus c. Okay, then I'm going to integrate again. So now I'm going to get f of x equals, okay, this is going to be 12x cubed over 3 plus cx plus d. And if I simplify that, I'm going to get 4x cubed plus cx plus d. Okay, now let's go ahead and plug these values in again. So I'm going to plug in x equals 0, y equals 1 into this equation. Remember, f of x and y are just the same thing. So if f of x is y, so I'm going to get y equals 1 equals 4 times the x values are 0. Remember, I'm plugging in zeros. So 0 cubed plus c times 0 plus d. Okay, cancel, cancel. Hey, d still equals 1. That's great news. Let's go ahead and plug it in. So now I have f of x equals 4x cubed plus cx plus 1 because the d equaled 1. Okay, now let's do it again, but this time plugging in x equals 1 and y equals 7. So I'm going to get 7 equals 4 times 1 cubed plus c times 1 plus 1. So this is going to give me 7 equals 4 plus c plus 1. Hey, this is so much better. So 7 equals 5 plus c, so c equals 2. So replacing the c value here with 2, I'm going to get that f of x is 4x cubed plus 2x plus 1. Okay, so that came out a lot better. Sorry about that. All right, let's do number 12. Okay, so you guys, this one, hey, there's several questions like this on your test, so please make sure you know questions like number 12. Okay, it says, if the integral from 1 to 2 of f of x minus c dx is 5, find the integral from 1 minus c to 2 minus c of f of x dx. All right, so let's try to figure this out, you guys. I see this integral from 1 to 2 of f of x minus c dx. Okay, you guys, I want this f of x minus c to be an f of x. So I'm going to go ahead and do u sub on this. So what do you think your u is going to be? It's going to be the inside of the f. So the f is, or so the u is going to be x minus c. Then your du is going to be 1. Remember, c is just a constant, dx. And when I replace everything, I'm going to get the integral of f of u. The dx becomes the du, and there are no leftovers. But I still have to replace my boundaries. So let's check that out. If I plug x equals 2 into here, I'm going to get 2 minus c for my upper bound. And if I plug x equals 1 into here, I'm going to get 1 minus c for my lower bound. Okay? And look, all of this still equals 5. I just did a u sub, but the answer is exactly the same. Okay, so what's the question? It says find the integral from 1 minus c to 2 minus c of f of x dx. Now, you guys, look at this. Everything's the same. 2 minus c, 2 minus c, 1 minus c, 1 minus c. F of u, f of x. It does not matter what the variable is. It's the same thing. You guys, this still equals 5. Nothing has changed. Okay, so the answer there should be B. And then let's look at number 13. Let's go ahead and do u sub on this. So the u on this one is going to be my 4 minus x squared. The du is going to be negative 2x dx. And then if I rewrite my integral, I'm going to get the integral of the square root of u. The dx dx becomes my du. But I have a leftover negative 2, which means I have to multiply by negative 1/2. So rewriting this, integral of u to the 1/2 du. If I add 1, I'm going to get u to the 3/2. You have to multiply by the reciprocal and then plus c. Let's multiply the fractions together. So I'm going to get negative 2 over 6, which is negative 1/3. And then I have u to the 3/2 plus c. And then I could just replace the u with what it was in the first place, which is 4 minus x squared. So this is negative 1/3, 4 minus x squared to the 3/2 plus c. All right. All right, you guys, there's page 3. I'm sorry for that horrific mistake that I made on there for not copying things over. If you want to see tomorrow, tomorrow we'll be doing page 4. So a little bit of these long division problems here. That might be a little exciting. Okay, hope you're enjoying your break. Have a good day.